All right, today in class we talked about properties of water, and this is just going to be a very brief video to review that real quick so that you do not forget. These are actually very important and will be relevant throughout the rest of the course, particularly when we are talking about different molecules and different things that happen when water is involved. So one of the first things that you need to know about water is the chemical formula is H2O. That means that it is an oxygen atom bonded to two hydrogen atoms. It is in this formation. Yes, it really does look like Mickey Mouse. It is always like that, and once you get into chemistry, you'll find out why. But this is important because right now you can see that there's two ends. This end where you have the oxygen is going to be a slightly negative end, and the ends with the positive or with the hydrogens are going to be slightly positive. When you have two charges like this means that the molecule is polar. Just like the Earth has two poles, two ends, so does the water molecule. The fact that it is polar makes it so that when you have multiple water molecules together in the same area, and remember the oxygen is negative, the hydrogens are positive, what we know about positives and negatives is that they attract. So you'll actually have a bond forming here. And the bond that forms is called a hydrogen bond. This is a very weak bond, but when you have many water molecules and they're all bonding together, then it's going to be very strong. So think about when you jump into a pool and you accidentally do a belly flop. It hurts because really all of those water molecules are kind of bonded to one another, and it kind of creates the film, almost kind of like a film on the water. And you may have heard of that being referred to as surface tension, and that is what it's called. But that surface tension is created by those hydrogen bonds. Now, in addition to having very strong connections, you need to know that water is a universal solvent. And what that means is that it's very good at dissolving many substances. Dissolves a lot of things. It can dissolve substances. It can dissolve sugar, salt, Kool-Aid if you want. It can dissolve many different things. It cannot dissolve everything, though. It really depends on the properties of the substance you are trying to dissolve. For example, it will not dissolve things like oil. So oil is considered hydrophobic. So this is water fearing or dislike of water. So the oil and the water, for example, in your salad dressing, they like to separate. They really don't want to be near each other. So even after you shake it up and you pour your salad dressing on your food and you put it back in the fridge, the oil and the water are going to separate again. They really, really don't like to be near each other. Okay? So it's a universal solvent. Also, this is something that is unique to water, and that is the solid is less dense than liquid. And this is true because you have seen it, you have witnessed it. Ice floats. And for biology, this is particularly important because when you consider lakes and ponds where you have living things, they'll freeze over in the winter time, but all those organisms can still survive because underneath the layer of frozen water you have still liquid water where they are still able to swim around. Okay, so ice floats, the solid is less dense than the liquid, and that really just has to do with how the water molecules connect with one another, but you don't need to know that much detail at this point. Additionally, water resists temperature change. That means that it actually takes a lot of energy, whether it is gaining energy or releasing energy before water changes temperature. And think about the example that we talked about in class with the beach. During the summer, it's really nice and warm. Everything is hot. The sand is hot. The water is hot. Well, it's warm. And then during the fall, the weather starts getting a little cooler. But the first thing to cool down is the sand, the land. The water is going to take longer time to cool. And the same is true in the spring. Now that it's been cold for a while in the winter, spring comes around, the land is going to warm up first. So even in the spring, if you go to the beach in April, the water can still be pretty chilly and not too comfortable. The fact that water resists temperature change makes it a good insulator. Good insulator. Okay. Think about, so we know that when we say an organism has good insulation, we usually think of something that has a lot of fat. So like a walrus has a lot of fat. We'll stick with that example. You can come up with additional examples. The interesting thing about fat cells, though, is that they are mostly composed of water. So it is really that water that is providing the insulation to that individual. All right, let's look at a couple more words and then we'll finish up for properties of water since we talked about this in class. Cohesion is when H2O molecules stick to each other. And adhesion, if something adheres, if something is sticking, there's water molecules stick to other substances. So we already talked about hydrogen bonds and how they can, when you have a lot of them, they're very strong. And that is cohesion. With adhesion, your water molecules are actually bonding to something else. So imagine that you have a glass of water and you have poured the water out. You know that inside of that glass, little water droplets are still sticking to it. That is because those water droplets are actually bonding with the glass. In biology, this is particularly important with plants. Plants actually have tissues, and we'll talk about this more later, but I'm going to draw my beautiful tree here. Trees actually need water at their leaves, but they collect water from their roots. Somehow that water has got to go against gravity up to the leaves. And the interesting thing about this is that since water molecules stick to each other and they can stick to other substances, there are tissues within the tree that kind of seem like little straws. And the water will climb up the straw just a little bit, but what ends up happening is that it pulls an entire column of water up. And if you think about a straw, putting a straw into your drink, sometimes you'll see the water level in the straw just slightly higher. I mean, try it. Take a look. Here's the straw, and here's the liquid outside of the straw, but the water in the straw might just be a little bit higher. And that's because it is kind of climbing up the straw and bringing the rest of the water molecules with it. So when we talk about cohesion and adhesion, it is very important for large plants to get their water. And this is actually called capillary action. The fact that this is a little tube, that's called a capillary. We have capillaries as part of our bloodstream, so our bodies do this as well. If you have any questions about properties of water, feel free to ask, email me, and make sure that you include this in your project, at least some aspect of water and how it is significant to our health.